A star is an astronomical object consisting of a luminous spheroid of plasma held together by its own gravity. The nearest star to Earth is the Sun. Many other stars are visible to the naked eye from Earth during the night, appearing as twinkling dots due to their immense distance from the Earth. Stars go through a natural cycle, much like any living beings. This cycle begins with birth, expands through a lifespan characterized by change and growth, and ultimately leads to death. The time frame in the life cycle of stars is entirely different from the life cycle of a living being, lasting in the order of billions of years. In this video, let us discuss the life cycle of stars and its different stages. So let's know. Stars come in a variety of masses, and the mass determines how radiantly the star will shine and how it dies. Massive stars transform into supernovae, neutron stars, and black holes, while average stars like the Sun and life is a white dwarf surrounded by disappearing planetary nebula. All stars, irrespective of their size, follow the same 7-stage cycle. They start as a gas cloud and end as a star remnant. A star begins life as a giant cloud of gas, which is generally an accumulation of dust, gas, and plasma. Stars form inside relatively dense concentrations of interstellar gas and dust known as molecular clouds. At these temperatures, gases become molecular, meaning that atoms bind together. Carbon monoxide and hydrogen are the most common molecules in interstellar gas clouds. A protostar is a very young star that is still in the process of gathering mass from its parent molecular cloud. The protostar phase is the earliest one in the process of stellar evolution. The phase begins when a molecular cloud fragment first collapses under the force of self-gravity and an opaque, pressure-supported core forms inside the collapsing fragment. These fragments initially contain about 0.01 solar masses of material, but increase in mass as the surrounding material is accumulated through accretion. A protostar looks like a star, but its core is not yet hot enough for fusion to take place. The luminosity comes exclusively from the heating of the protostar as it contracts. They are usually surrounded by dust, which blocks the light that they emit, so they are difficult to observe in the visible spectrum. The stage of stellar evolution may last for between 100,000 and 10 million years depending on the size of the star being formed. If the final result is a protostar with more than 0.8 solar masses, it will go on to begin hydrogen burning and will join the main sequence as a normal star. For protostars with masses less than this, temperatures are not enough for hydrogen burning to begin, and they become brown dwarf stars. When the star is still in the earliest stages of formation, it doesn't have enough temperature in its core to ignite fusion of hydrogen and helium. Instead, the star shines with just the gravitational energy of its continued collapse. Astronomers call this pre-star a Tauri star. This early stage lasts about 100 million years before nuclear fusion kicks in, and it becomes a true star. In this stage, a young star begins to produce strong winds, which push away the surrounding gas and molecules. This allows the forming star to become visible for the first time. A star in its Tauri phase can be spotted without the help of infrared or radio waves. If the body has sufficient mass, the collapsing gas and dust burn hotter, eventually reaching temperatures enough to fuse hydrogen into helium. The star turns on and becomes a main sequence star, powered by hydrogen fusion. Fusion produces an outward pressure that balances with the inward pressure caused by gravity, stabilizing the star. Main sequence stars fuse hydrogen atoms to form helium atoms in their cores. About 90% of the stars in the universe are main sequence stars. These stars can range from about 1/10 of the mass of the Sun to up to 200 times as massive. Our Sun is currently in its main sequence phase. When all the hydrogen in the star is fused to helium, the core contracts and its temperature increases. This increased core temperature and pressure cause helium to fuse into carbon via the triple alpha process. This fusion releases more energy than hydrogen-helium fusion, causing an increase in radiation pressure. This increased radiation pressure pushes matter outwards, thus expanding the star. As the star expands, its surface cools and becomes red, or a red giant is formed. Red giants have cooler surfaces than main sequence stars. Because of this, they appear red rather than yellow. A red giant star is a dying star in the last stages of stellar evolution. In only a few billion years, our Sun will turn into a red giant. It will expand and engulf the inner planets, possibly even Earth. Nuclear fusion in stars converts hydrogen into helium. In stars less massive than the Sun, this is the only reaction that takes place. In stars more massive than the Sun, but less massive than about 8 solar masses, further reactions that convert helium to carbon and oxygen take place in successive stages of stellar evolution. Once helium fusion ends, the core shrinks, and the star begins fusing carbon. This process repeats until iron begins appearing in the core. Iron fusion absorbs energy, so the presence of iron causes the core to collapse. In the very massive stars, the reaction chain continues to produce elements like silicon up to iron. The death of a star results in a luminous stellar explosion. A supernova explosion is one of the brightest events in the universe. Exactly how a star dies depends in part on its mass. Our Sun, for example, doesn't have enough mass to explode as a supernova. Most of the star material is blasted away into space, but the core implodes into a neutron star or a singularity known as the black hole. Less massive stars don't explode. Their cores contract instead into a tiny, hot star known as the white dwarf while the outer material drifts away. Stars tinier than the Sun don't have enough mass to burn with anything but a red glow during their main sequence. These red dwarfs are difficult to spot, but these may be the most common stars that can burn for trillions of years. Low-mass stars turn into planetary nebulae towards the end of their red giant phase. At that point, the star becomes highly unstable and it starts to pulsate. The resulting stellar winds eject the outer layers. Planetary nebulae are relatively short-lived and last just a few tens of thousands of years. The above were the 7 main stages of the life cycle of a star. Whether big or small, young or old, stars are one of the most beautiful and lyrical objects in all of creation. Next time you look up at the stars, remember, this is how they were created and how they will die.